Hi everyone, are you able to hear me and see my screen clearly? Hi everyone, this is the first time we are turning on the video, and because some of the people complain that it becomes too monotonous, so I'm planning to keep the video today. All right, so hi there. We're going to talk about big data with Spark and a bit of Hadoop. So we're going to start with introduction of big data. Then we'll take a 10 minutes break. Then we will go into the details of Spark and Hadoop architecture. Since some of you had requested that why only Spark, why don't we give a brief of Hadoop as well while we are doing it? So we decided to keep a bit of Hadoop today, and we're going to just go over the architecture, and then we will get into Spark. All right. So we are going to do the hands-on on Spark. If you want to do it together with me, either you could set up your own virtual machine, or you could take a 7 days subscription of CloudX Lab for free. The 7 day subscription is there for free at CloudX Lab, so that you don't need anything to install or download. All right. So we're going to start now. All right, so hi there. Hi, everyone. Great to have a wonderful audience. I'm sure that the audience is going to go beyond 100 in these sessions. And today, this is the first time that we have turned on the video. And I'm going to answer your questions. So I'll turn to this side while answering the question, and we'll look at the camera this side while explaining a concept. All right. So essentially, this session is of 3 hours. The agenda is mainly big data with Spark and a bit of Hadoop, because some of you requested that why don't we have a bit of Hadoop as well. That will basically complete the whole ecosystem. So we will start with big data. What is big data? Why do we need it? And so on. Then we will take a 10 minutes break in the middle of session, which is 1.5 hours from now. Then we are going to talk about Spark and Hadoop architecture, and then we will do a hands-on on Spark. All right. So please introduce yourself using the chat window while others are joining. This session is being recorded, and the recordings along with the presentation will be shared with all of you. But that does not mean that if you want to take a screenshot for your blog or for your own notes, feel free to take a screenshot, as well as at later point of time, you can take the screenshot from the recordings itself, or you can just keep the recordings. All right. So we basically we conduct these sessions globally, and these sessions are being done for last 3 years, and a lot of people across the globe have attended these sessions, close to 40,000 people so far. And this is the first session out of the 10 sessions that are remaining in the big data with the Spark ecosystem. It suffices as an introduction to big data stack. Except for me, everybody is muted. So please ask your questions in Q&A window. Again, Q&A window is for you to ask questions to me. You will be asking questions to me by using the Q&A window. And when I ask the question, you reply to them using the chat window. All right. So I will read out the questions before answering. So to get better answers, please keep your messages short. And short does not mean the SMS language or chat language. Short means it should be crisp and clear. All right. I'm okay with a little bigger message because I'm pretty bad at the chat language. So please feel free to ask questions. These sessions, the purpose of my sessions is essentially to answer your questions, because the content is available all around on the internet, on YouTube and everywhere. So I would these sessions at CloudX Lab are basically for answering your questions. All right. So feel free to ask your questions and come over to our forum or drop an email to reach us at CloudX Lab if you have any questions. So with me, I have Abhinav, Ashwath, Tarun, and Malvika. Ashwath and Malvika take care of the user satisfaction as well as user counseling. If you have a question related to buying something or taking up the course, so Malvika or Ashwath can be reached out to. And our common email ID is reaches@cloudxlab. Also with me, Abhinav and Tarun. Abhinav and Tarun work in the big data and machine learning domain, along with the projects that we do at CloudXLab. And if you have any technical questions, reach out to us. Either of us will answer your question. All right. So they will also be answering the questions in the session along with me. All right. So wonderful to have all of you in the session. I'm sure that you will like the session. I'll try my best to answer your questions, and I'll try my best to explain in simple words and in simple language the whole ecosystem. Other than explaining, I promise to do some hands-on at the end of the session. So during the break or during whatever time you get, if you want, you can just take a subscription, free subscription at CloudXLab so that you can do the hands-on right away instead of downloading or installing. All right, that's the purpose of CloudXLab, so that you don't need to install any of these softwares. Instead, you can just instantaneously get the account. All right. So wonderful to get your, so please ask your questions using the Q&A window. And a question from anonymous attendee is, I'll prefer the name, even if you keep a pseudonym, it's completely okay with me. All right, I love to address one-on-one. The question is, will we be talking about Scala today? So today it will be difficult, but I will do one simple example on Scala, and I'm sure you will be able to make out the code. And it'll be difficult for us to do a session on Scala today. But what I suggest is that go to CloudXLab. There will be a course, a chapter on Scala, which is free, and you can learn right away. All right. So our agenda is mostly making the learning quick, simple, and memorable. As that's the plan that we're working on. All right. So let me, this is part of the big course called Big Data with Hadoop and Spark Specialization. And that course includes the entire big data and Hadoop and Spark ecosystem. So this session is the part of the big course. All right. So this one suffices as the introduction to the entire big data stack. So if you have already been through these sessions, you can stay back or join back later while we do the hands-on, because most of this is going to be very similar to what we have done earlier. All right, but feel free to ask questions using Q&A window. I love to answer your question. Question from Soumya is, the hands-on that we're going to do today, on which programming language will it be based on? It'll be based on Scala. All right. Great. Right now, I may not be able to read the chats, but I will be answering. I'll be keeping my eye on the Q&A window. All right. Great. So at CloudXLab, the idea is that we are trying to make learning fun and for life. So we have videos or live sessions like this, and like this, as in the video won't be there in the normal one, as well as the questions you could ask, because there's a small audience, questions will be asked using the chat window. And if needed, we can unmute and you can talk in the normal session. So we are making learning fun by the way of videos, live sessions, and quizzes, hands-on assessments, and projects, along with the case studies. So all of this is based on real life use cases, and that's what CloudXLab is specialized at. All right. So one of the things that we innovated at was the hands-on assessments. Hands-on assessments are automated assessments in which you have a problem statement, and then you have hands-on based on the cloud-based lab, the one that we have created. And automatically, when you are given a challenge and you finish it, it does the assessment for you. All right. So let's take a look at this example that you see in the screen right now. So here is a very simple challenge that you have to log in, and then you have to click on I am done, please check. So once you have actually logged in and click on I am done, and then it will automatically check and say, congratulations, you have successfully cleared the challenge. Similarly, there are harder challenges and so on. So if you have time, you can right now explore how it works by just joining the CloudX Lab, as in signing up with CloudX Lab and taking up the lab. You'll get the Linux course, Python course, and Scala course, and many other shorter courses for free. All right. So the other example of automated hands-on assessment is this one. On the left-hand side, you have a very simple Python challenge. You see that there is define x as 10. And on the right-hand side, you are provided with a notebook in which you have to write the code. So once you have written the code like x equals to 10, and you have defined x as 10, then you go back to this side here, and then click on it again, and then it says that congratulations, it's a good job because you have defined it. If you don't define it correctly here, it is going to give an error. So this is something, that innovation that we are doing, and there are quite a few innovation that we are trying to bring in to the machine, to the online learning experiences. So we are innovating and trying to bring a user experience whereby everybody can learn quickly and can learn practically. All right. So about me, I'm Sandeep Giri, and I graduated long back from IIT Roorkee, and I mostly worked on large-scale computing. Right? For example, I worked at Amazon, InMobi, and Deisha. Deisha was my first job, where that was my first introduction in 2002 to distributed computing. We had a 10,000 node cluster long back in 2002. And those who are not aware about who is Deisha, that was a company where uh, Jeff Bezos worked, right? Jeff Bezos is Amazon's founder. So Deisha was one of the companies in the world who did the distributed computing long back before everybody else, right? Then I worked with InMobi, where I worked on 200 terabyte data in order to come up with recommendations and so on. Then I worked with Amazon. At Amazon, I built a high performance engine and the mobile version of their detail page, the detail page where you click on buy now. Those two projects I built from ground up. All right. So at heart, I'm a software engineer, and I am very proud of being software engineer. And I love explaining technologies to everyone. And that's the reason why we started CloudX Lab. The purpose of CloudX Lab was because there was lack of practical education and lack of engineers who were trained in practical education. So we started CloudX Lab. It was earlier called No Big Data, KNOW Big Data, but now it's called CloudX Lab. All right. So we started the CloudX Lab with the vision that will be with the vision of filling the gap between the industry and the academia. So we are working on it. We are providing all kinds of tools and technologies so that people who want to learn, they can learn instantaneously and in a real environment. All right. So that's the sole idea. So the objective of the course is basically it's part of the whole course is to process big data with Spark and Hadoop. So we are starting the Spark session from next Saturday. And so if you want to enroll, you can enroll. There are a couple of seats, I think 2 or 3 seats remaining, and you're free to join the course. All right. So at CloudX Lab, you can find the Spark course, Big Data with Spark course, and that you can join. All right. So let's get started with the basic definition. So the way we are going to proceed is we're going to cover the basic terminologies. Then we will cover the case studies. And afterwards, we are going to cover the architectures of Hadoop, and then the architecture Spark, and then hands-on. So that's the kind of format. And we're going to answer almost all the questions. So we are going to spend a very less time in teaching you theory. This is the most theoretical part that we did so far. Afterwards, we are going to teach less theory, answer your questions more. All right. Feel free to ask questions, and I love to answer questions. All right. So a question is from Anmol, how to get a job in Spark and Hadoop as a fresher, as it needs 7+ years of experience. I work on many projects using Spark, Hadoop, Kafka, Storm, and Cassandra. Please help. All right, good question. It's a challenge probably with almost every technology, right? But every fresher faces this challenge that how should I get in? How should I get in? So nothing to worry. So if you are a fresher, um, you should not hesitate in picking the normal software engineering job. All right. Not many companies right away open up for machine learning or big data kind of roles for freshers. So my recommendation is, though, join as a software engineer anywhere. And that does not mean that learning Spark is going to hurt you. It's going to improve your chances because you because if you are good at, say, traditional technology, say Java or say uh, databases, it's hard to compete for a fresher, right? But if you are working on a relatively new technology, it's easier for a fresher. So your chance of getting a job is higher, though you may not get immediately a job in the data engineer or data architect, but you can join as a software engineer or you can join as a junior data engineer, and then you can walk upwards, right? So you start with say SQL kind of job or normal programming kind of job, and then you will automatically do a very good progress. So if somebody is good at technology which is new, that essentially shows that the person has interest in learning by themselves. All right. So your chances do improve, but there'll be discouragements when you see the holding this the job definitions asking for 7+ years of experience. So do not get discouraged. In that case, you must apply. They may not reply, but you may apply for other junior roles. And yeah, so that's I hope I was able to answer your question. Thank you, Anmol, for a good question. All right. And all right. Thank you, Satvik, for a good answer. Satvik says that, Anmol, please provide your work on GitHub. Yes, that's a good answer. Thank you, Satvik, to add. So Satvik's suggestion is that just prove your work on GitHub and take up challenges on Kaggle. You will surely get a job. Kaggle, HackerRank, or say Codility or HackerEarth, those are the various platforms where you could prove your programming or data science experience. All right. So make yourself comfortable and be open to learning. Be open to learning new technologies. Computer technology job, any job for that matter, in today's knowledge industry, demands that a person should be adaptable. All right. So th this sounds like a contradictory, right? It sounds like contradictory. I'm learning because I don't have to learn again. No, you're learning because your future learning becomes easier, right? Even for a person like me who has, say, 16+ years of experience, if I stop learning, probably I won't get a job anywhere. All right. So my suggestion to all of you is, no matter whether you're fresher, whether you are experienced person, keep learning new technologies, existing technologies, master yourself in things, work with a genuine curiosity, and you'll have a great career. There's a lot of jobs in demand who are looking for people who are passionate about computing, who are good at computing. All right. So be good at that. And though there'll be setbacks in the beginning of the career, like every job, but there are uh, great opportunities. Like you can start working as an intern, and then right, maybe you can just offer to a startup that, hey, I'm ready to work for 2 months for free. Can you give me a data engineer job? So there are high chances. So leverage LinkedIn, leverage, say, AngelList, and that would help you out. All right, if you are a fresher. So thank you, Satvik, for a great suggestion. All right. So I'm going to just go over some more questions related to career, and because these are the common questions and we all face these questions at one point of time. Okay. A question from Ravi is it recommended to attend this session if we already enrolled for Spark course? Yes. So in case you are through with the big data introduction, as you are okay with the big data and the ecosystem, then you can skip this session. You can join from the next session. And but I would request that maybe last 1 hour you should join, because there I'm going to talk about hands-on more. All right. A question from Soumya. I have 4 years of experience in software engineering, Java, Unix, and database. How can I get a chance to build my career in data analyst as I don't have experience in technology? All right. So you have Soumya. All right. This is again a good question. Probably most of you would be facing this dilemma that I am okay with the basic software engineering like Unix, database, and Java. So that's a good thing, Soumya, that you have, because these are the foundational technologies. Those who are not comfortable with, say, Linux or Unix, just take a look at the tutorial we have created at CloudX Lab. If you scroll down on the front page, you will see the Linux. You can just quickly finish Linux in 2 days, and that would help you. So the other thing that's very important in the career is the databases. You should be comfortable with SQL, the basics of SQL, like joining, selecting, grouping, and then aggregating, and say doing the bit of the queries between the tables. All right, so that is good enough. And the third thing is learn any one programming language, whether Python, Scala, or Java, or say JavaScript. Learn at least one programming language. Be comfortable, because what's happening is every job in the world is going to be in one way or another, whether you go for manufacturing, whether you go for agriculture, whether you go for, let's say, banking. Probably every job at the higher level is going to be programming. And these three technologies are the foundation. These three parts, the SQL, operating system like Linux, and the programming, these three things are like foundation. So you cannot live without any of these if you are getting into computing. And most of the high level work is going to be on the computing in every industry. So it's good that you have this good experience. Now, a question, the real question from Soumya is that how can I get the chance to build my career in data analyst, data science, as I don't have experience in the current technology? So, uh, all right. So good part is that you have good foundation, and trust me, not many data scientists or data engineers are available with a great experience, with like more than 1 year experience. So if somebody is asking for experience specifically in data analyst or data science, even then you should apply for a job, because actually they don't know that they're not going to get a data scientist with 4 years of experience and 10 years of experience so easily, because those kind of people are already doing a good job. All right. So my suggestion is that you don't need to be discouraged. You will definitely get a job. The only thing is make yourself good with, say, data science techniques. So I will recommend that since you already know Java, just get yourself comfortable with Python. Python, why I suggest Python over R is because Python, you can do everything in Python. Plus, you can do web development with Python, as well as it lets you do a lot of system engineering like automation and other things with Python. So I would suggest that get started with Python. Start with, say, free machine learning course, the one that we are launching, or if you want to go into the machine learning area, you can start with a machine learning course, or you can start with, say, data engineering, kind of like big data, and big data with Hadoop and Spark. Focus on more on Spark, because Hadoop part you will quickly get it. So I would suggest that if you are focusing to get into the data engineering, focus on the big data ecosystem with Spark. And if you are planning to go for data science or machine learning scientist kind of role, there also you will need Spark, parts of Spark. So there you will need the knowledge of machine learning along with the knowledge of Spark. So I generally suggest that people to go with big data with Spark, and that should be sufficient. All right. So I hope that answers your question. And of course, the things like maintaining your GitHub profile, as in maintaining some projects, maintaining good LinkedIn profile, along with being open to the discussion at LinkedIn and being open at say Angel List would improve your chances at any time. So all right, so those are the things you should keep in mind. All right, so a question from, all right. Oh, I actually, okay, so I had actually just marked somebody's answer as, okay, I'm just answering. A question from Arun is, what about people who want to switch to big data after 5 years experience? Yes, you can definitely switch. The answer is same as what I answered just now for Soumya. So you can definitely switch. And um, most of the big data people are generally looking for people who know Unix, who know SQL, and who know any programming language. So you can, if you have 5 years of experience, it'll be quite easy for you to switch to big data. All right, finish any of the courses either by yourself or at CloudX Lab, either of the courses on big data with Spark and Hadoop, you should be good to go. All right. Great set of questions. There are 8 more questions. Let me see if I can answer. I have 3+ years of experience in Java, Spring, and Hibernate, but I don't have, okay. All right. How do I get job related? All right. So that's a question from Subra. Subra, my answer is same as what I answered to Soumya, that, all right, you also have a good background. If you don't have a background in SQL and Linux, make yourself comfortable with with SQL and Linux. I'm sure you will be quickly able to do it because that you might have already touched when you were working on Hibernate, Spring, or Java. And therefore, a course like CloudX Lab, the one that we're talking about right now, that course should help. Okay, so take a look at CloudX Lab and take a look at the appropriate course with big data with Spark and Scala, the one that we are starting today. That should be good for you. All right, great set of questions. A question from Anmol is as a follow-up question. Good. So I too won National Big Data Hadoop Championship in IIT Roorkee, but is still not able to get into this domain. All right, this is good. So why don't you at least get in touch with us? Drop me an email at reaches@cloudxlab. I would love to have a discussion on one-on-one. All right. So it's good that you came forward and all right, you came forward and discussed it. So come over. I would love to discuss in one-on-one. All right. So a question from Aryan is, I'm pursuing CA. Does this session going to help me? I'm finding all these related to technology. This session is on technology. So if you want to get yourself familiar with common terms, then be around. Some parts may be too difficult, too new to you, not difficult, new to you. So I would say that all right, let go of the ambiguity, ask questions, and stay around. There is no harm if you don't have any other thing to do. Stay around, and I think this session is not going to harm you. All right, so great, and I'll try my best to be simple. Okay. A question from Manisha is that, can you please answer all these questions so we can continue? All right. Thank you, Manisha. All right. So our sessions, though this session is having a lot of audience, around 100 audience, um, though this session has a lot of audience and there would be a lot of questions, but as a principle, we want to answer everybody's question. But I'll try my best to be short and simple. All right, so that we can continue with today's agenda. And I'm sure that all right, I'm sure that uh, I don't want to discourage anybody from asking questions. So I hope you will understand that part. And that's kind of our principle, that we want to answer everyone's question. So I hope you'll be comfortable with that. All right. So I'll try my best to be short and crisp. Uh, and if somebody needs more details, we are open to discussion, either using our discussion forum or using reach us at CloudX Lab. All right. So a question is, how can I transition as a full stack data scientist? Right. So if you want to go with full stack data scientist, I would suggest that you will have to go with Spark, as well as you will have to go with machine learning course. Those are the two big pieces, and they will definitely help you. All right. So it's kind of, it'll take you around 6 months, but I can assure you that this will, make you, this will, after all of this, you'll be able to solve hard problems on data science as well as the data engineering. All right. So though there are all kinds of definitions of data scientist, but we consider data scientist as somebody who knows machine learning as well as data engineering. So those are the two parts, and those are the two courses that we run. A question from Venkatesh: I'm predominantly as a PLSQL developer, strong at SQL side. Okay, basic knowledge in Java. Is there an approach transition? And all right, this is good. So I have had many similar learners like you, and many similar learners like you, and I can assure you that going with, say, big data with Spark or Spark SQL, either by with us or somebody else, or by just attending our free course, that'll be good enough for you to start transitioning into the career, into the big data engineer career. So you should generally aim at big data architect or big data engineer kind of a or data engineer kind of a career. And this is probably your logical move, because you already know SQL, you already know Java basics, and Java means any programming. Just comfortable with basic construct should be good enough. And you would be, I'm assuming that you'll be okay with the operating system, like basics of Linux. If not, just go through the tutorial and you'll be able to transition. And though normally people want to go with certification, but I'm not a big supporter of certifications, because today most of the serious companies who are serious about big data, they have their engineers who can interview you on the basis of big data. So my strong suggestion to you will be that make yourself comfortable with the concepts, try to solve problems on the big data platforms, and you will be comfortable with the interviews. And if you wish, you can go with any kind of certifications. All right, though certification is not really hard and fast rule. Certifications are needed by the industries who don't know the subject really well. So I'm not sure if you are joining a company who is not into big data just based on certification, your career will improve. Because if you are the most knowledgeable person in a company on big data, I'm sure that you are not going to have that great learnings in the domain. So generally, I prefer that a company who interviews a candidate based on certain big data problems or so, I generally prefer to join such companies, or I generally advise my learners to join such companies. All right. So great questions. All right. So it'll be easier. I think I hope I answered your question. Feel free to drop us an email or come over to the discussion forum. All right. Okay. So Dilkesh, I think. Okay, so I think answer for you as well is the same, that you have done the foundations and you have a basic knowledge of, right? So you can just go ahead with the Spark course anywhere, either at CloudX Lab or elsewhere. All right, that would help you out. Okay, great. So, all right. All right. A question from Srikant is, I don't know anything about Java and I have a mental block about Java. That was the one reason why I moved to SQL and now to Python. How critical is Java for Spark ecosystem? Can everything done in Java or Scala be done in Python? Good question, Srikanth. So one, I'll suggest you a very simple thing. One, don't worry about Java as such, right? Java, as in there is just too much of syntax. So I too find it like if somebody asks me to solve a problem quickly, I'll choose Python over Java, right? And probably you have a mental block because there's just too much typing involved, correct? So good news is that on one hand, Python is really great. On other hand, Java was really fast. Now the Scala is between them. So Scala has the syntax like Python, which is heavily inspired by Python. Scala is heavily inspired by Python, right? So it has a syntax like Python, while it has the speed of Java. So you get best of the both worlds. So your problem is solved by Scala. All right. So I'm sure that you will enjoy a Scala session. All right. So you go ahead with CloudX Labs Scala chapter. That's, I think, free and you can just join right away. All right. You can just go ahead and go through sequence of topics and you'll be able to get through. All right. So I hope I've answered your question. A question from Sam is that my experience is over 12 years in mainframe and I don't know Java or Linux. How can I pivot into big data? So my simple suggestion to you will be just go over the Linux tutorial and that would basically make you comfortable with the environment. And then you can join a course like Big Data with Spark or Hadoop or the entire stack. Then that would help you in getting into the domain because uh, generally you don't need Java. You just need a basic familiarity with any programming. All right. So I always recommend you or everybody, even I have taught um, Python to my wife, who is a English graduate. So my strong suggestion to everyone is get yourself comfortable with a very simple programming language such as Python. It's just a little bigger version of a bigger version of a normal calculator. All right, so that's how you can look at Python, and that will make you really comfortable very quickly. So I think for you, I have two suggestions. One, start with Python right away, as well as start with Linux right away. All right, so those were mostly SQL is SQL considered a programming language? Yes, it's a programming language, but the SQL is not. You always will have difficulty in solving all kinds of problems with SQL, right? A lot of problems involve using for loop, while loop, and other things, which are not really possible using SQL or the standard version of SQL. Also, you will have hard time. Let's say you want to build a simple application on or web application or Android application, you will have a hard time in migrating there. So my suggestion is if you are good with SQL, start with a simpler programming language like Python. And then you can, once you are comfortable with one programming language, rest of the magic will unfold. All right. I can assure you that. All right. So a question from Ananda is that 10 years of experience is C++, good SQL, great. I don't have it. That's okay. Is it okay if I move to, yes, it's completely okay. And you will do great. All right, you will do great because the kind of languages you have experience with, they are kind of supersets. And when you were able to do programming in C++, you will be able to do in Scala, Java, or any other. So there won't be any problems at all. Also, most of the work can be done still with C++ in a distributed environment. So you will have a great time. All right, whether you want to go for machine learning or big data, either of them, you will do good. All right. So, all right. So great. I think both the questions from Mithran and Sanant, I have similar answers for you. I would suggest that drop us an email at reaches@cloudxlab or come over to the discussion forum or one of my teammates will reply to you. Your questions are good. And your questions, I would answer in the similar way that the way I've answered to Soumya and other people. All right, great. All right, so let's get started. Let's get started with the session today. All right. All right, I'm just checking if there is a critical message for me. Okay, great. Great. Wonderful. Wonderful to have all of you in the session. So let's get started with today's ideas. I'm going to go really quick with the ideas, and then if you have questions, you can ask. All right. So generally, the data is classified as structured, semi-structured, or unstructured. All right. Even if you don't know this definition, it's completely okay. It's just the terminologies when you hear and when you meet people, these terminologies might make you feel that I don't know anything. That's why we have kept the terminologies upfront and clear, right? So structured data is something like a tabular format, like the databases, where you have the clarity on what are the fields. You have a clarity on what are the data type of each of the fields, each of the columns, what are the data types. That's the structured data. Then we have semi-structured data. Semi-structured data is where you have idea about what are the fields, but we don't know their data types, or there is a slight bit confusion about the data types, or you don't have a clarity. You need to do the probing and analysis of the data in order to come up with the data types. That kind of data is called semi-structured data. The third one is the unstructured data. What is unstructured data? Unstructured data is where you have neither knowledge of any fields nor you have the knowledge of data types. Like, for example, meaning the data is not in tabular format and neither each of the columns have the same data types, right? In semi-structured, the data is in tabular format, but the fields don't have the same data type, or they don't have like explicitly defined data types. So in like an Excel sheet, you generally have semi-structured data type because not all the values in the same column have the same data type, right? And like in databases, we have structured data because we have clearly defined tables, and each column can only have the data of the data type that we defined at the time of table creation, right? While unstructured, we don't have anything like, for example, plain text file. Now you may ask that where do we get the plain text file? Plain text files are very common in the industry. Well, let's say, for example, when you hit a website, when you open a website, on the website, it makes a note that such and such person accessed the website, and it is stored in a file. That those files are called log files, and these log files are essentially the unstructured data, because these are plain text files. In order to figure out what are the columns and what are their data types, we need to parse the data. And this parsing of the data is called ETL. Converting an unstructured data into structured data is called ETL. ETL stands for extract, transform, and load. Extract, transform, and load. So this is called these are the three terminologies, and the four terminologies ETL. ETL, there are many ETL tools, and if the data is really big, then you have the Hadoop as ETL tool or Spark as ETL tool. All right, ETL tool could be a program, it could be an existing software, it could be your databases, and so on. So ETL is a general terminology, and there are many tools to do ETL, and Hadoop, Spark are also used for the same. All right. Now the next term that you will see all the time is distributed systems. Distributed systems is not a new term. It has been there for very long. So when you group the when a group of networked computers interact with each other in order to achieve a common goal, then we call it a distributed system, right? A distributed system. A question to all of you, you can answer using chat window. Is a computer center, when you go to a computer center, you have computers. Is a computer center an example of a distributed system? Like in a cyber cafe, not computer center. In a cyber cafe, you have individual machines, everybody chatting with somebody, or people are sending emails, or people are checking their bank accounts. So is a cyber cafe a common place where people go to check their emails? Is an example of distributed system? It is not, right? Why? Because the last line, the third one, you see, the third one is to achieve a common goal, right? Group of network computers interacting with each other to achieve a common goal, right? In a cyber cafe, you don't have that. All right, so this is the distributed systems. Okay, all right. Okay, let me just take some water. Great. So common goal is a single common goal is, when we say common goal means solving a problem, distributing a logic to multiple computers so that the work can be distributed amongst computers. A big piece of work being divided into multiple computers and then using the computers in order to solve that. All right, great set of questions, great set of answers. All right. Now, the next thing is, the next question I want to ask all of you is, how many bytes are there in 1 petabyte? Okay. Yes, this is just to check if you are really responding. So come over near to your laptop or tablet and answer the question. Okay. So, all right. All right. If you are answering in the precision, that means you are Googling. Okay. You just give like an estimate, like how many zeros will there be? All right. For example, the answer that I'm going to give you is actually the Googled one. Okay. All right. Great. Great set of answers. So yes. So it has around 15 zeros. So this one is a Googled answer. And so it has 15 zeros. That's the one important part. So though this looks like a very small number when you look at the paper, right? But this is really, really big number. Okay. And let's take a look at some more numbers. So another question to all of you is, how much data Facebook stores in 1 day? How much data Facebook stores in 1 day? Just any guess. It's not an exam where we are, judging your precision. It's just to, quiz you on the kind of estimates that we're going around, right? So around 600 terabyte data they store every day. Okay, 600 terabyte. Okay. Yes. All right. Now I'm going to, yeah. So although this number looks like really small, but when this kind of data comes into play, almost every computing that we learned so far does not scale up. It doesn't add up to handle this kind of data. This I realized when I was with Deisha, and the kind of data I needed to process every week, we thought that, okay, we will download the internet. We had got like 1 Mbps internet that time. 1 Mbps was a big deal that time. So we had around a few 100 GB data that time we wanted to download. And so it's an important point. So when we, on the prima facie, these numbers look really nice, and when we talk about it, when you want to handle them, the entire mechanics changes. The way Newton's law do not apply when the things become at the speed of light. In the similar way, when the data grows to this size, your normal common sense of IT does not apply. For example, at Disha, I thought, okay, what big deal? We'll just download the data. And I realized that my 1 week's data has not been downloaded in last 1 week, right? Because of many reasons. So we try to do all kind of things like do partial transfers, use all kinds of techniques to do that, but no, the speed was not adding up. We realized that the speed is not good enough. And at this speed, we will be able to download this data in a month's time, and a fresh data will come next week. So then the solution was to just fly the data from the US to Hyderabad in India, and that kind of solved that problem, right? So when now you can imagine that the aeroplane is faster than the electron, right? When it comes to this kind of data. So this is an important part when we talk about big data. The dynamics changes, and hence the entire mechanics changes. All right. So all right, let me try to see if you know about big data already. So please feel free to answer this question. What is big data in your opinion? All right. Yes, Srikanth. Even today, AWS physically transferred data using Snowball. That's correct. And when I looked at that, I laughed, and then we did this kind of thing long, long back. Yes. Okay. All right. Great set of answers. Keep the answers coming. So what do you think is the meaning of big data in your opinion? What is your understanding? Yes, Nikhil, you have a question. You have raised a hand. You could ask the question using Q&A window. All right, you can answer using chat window. There are two windows. One is called chat, other is called Q&A. So answer the using Q&A, answer using chat window, and ask using Q&A, because I'm keeping my eyes on the Q&A window, and occasionally I'm looking at the chat window. All right, so moving ahead. Great set of answers. I'm going through your answers. So a last set of information used to tackle some problems or to do some analytics. It cannot be stored in RDBMS, granularity of data, and 3V, okay? Lots of data, large chunks of data, more than terabytes, which can handle, good. Great set of answers. Let me uh, try to answer. All right, there is a bit of different question from Nikhil. So I'll just answer your question, Nikhil, and right, even though it is a bit of kind of, different, but I love to answer your question. Is blockchain technology system is a distributed system? Yes. It is distributed because it utilizes many computers to do the mining. All right, and parallelly. So it distributes the work to many computers, and therefore the Bitcoin is definitely distributed. Peer-to-peer is distributed, like when you download BitTorrent, that's a distributed. When you, let's say, are running a NoSQL system on multiple computers, that is distributed, and so on. All right, or partially sometimes when we are load balancing a system, sharding the system, that is manual distributing, but it is still distributed computing. All right. Chandu's question is, what storage blockchain uses? Blockchain basically stores the data on a distributed environment on many people's computers. So therefore, it is heavily distributed. All right. Those are the examples of extreme level of distribution. Great. In simple words, most of you have answered the question correctly. In simple words, the data of very big size. Since every tool as part of this course, we're going to talk about big data tools. Therefore, it is very important to define the big data in very simple words. So big data is simply data of very big size. All right. Now, a common question is how big size, right? Because it is completely subjective. So the further answer is that you cannot process with usual tools. Now, here there are two words that are subjective. One is process, and other is usual, right? Usual tools as in your usual file system, your usual databases. That's the meaning of usual. And usual tools essentially means the tools that are not distributed. And can't process means process could be really simple, like putting the data from here to there. That's a simple processing, or converting a plain text file into a comma separated file, or into a column format file or a tabular format file. That is a simple example of process. A hard process, some process could be like machine learning process, in which you have so much of CPU usage and so much of work to be done in order to process it, or let's say optimizing an image or optimizing a video. Those are examples of uh, uh, time-consuming activities. So processing could be anything. It is up to you. That remains still the subjective. The most important keyword here is the big data, those tools which have distributed architecture. All right. So when you cannot handle the data, when you cannot do the processing of your data using usual tools, then you require the distributed architecture. And when you require distributed architecture, that's called handling the big data. So most of the big data tools, or almost all of the big data tools, are distributed in nature, meaning they divide the work on the network. Whether we talk about Hadoop file system that basically uses many files, many computers to store data. When we talk about, say, HBase or NoSQLs, they all store data and process data using many computers simultaneously. As well as when we talk about, say, Hive or say Spark, they all distribute the processing on multiple computers. So that's what is the definition of the big data. The data could be any format, structured, semi-structured, or unstructured. Now, this is standard definitions. So this is standard definition about data, not really big data. So the data, when we talk about in terms of volume, how much do we need to store? Then we talk about what kind of request will be coming from the users, or at what pace do we need to transfer the data from one point to another. The third thing that we want to ensure is that what kind of data, and this kind of data is very, again, has two forms. One, the kind of data we want to process, right? Or the kind of complex program do we want to run on that data. So this third variety basically refers to two things. One is the format of data and the kind of format or the kind of work that we need to process. Okay, so when we say data could be in terms of storage, data could be in terms of transfers, data could be in terms of the format or the complex structure. So when you are dealing with the data, if you are taking, if your problem starts with the, hey, where will I store this data? I can't store it on one computer. Let's say you have to store, say, 100 terabyte data. You can't really store it on one computer. Therefore, you will need multiple computers in order to store the data. That is the problem related to volume, right? If you think about, say, a website storing all the logs, or say Gmail storing all the emails in a file and so on, and Facebook storing so many videos and so on, that's volume issue. Okay, so the kind of issue that you could face, the kind of problems, the challenges that you could face could be related to volume, right? Such kind of problems are generally solved with, say, Hadoop file system or any other file system. The second one is velocity. Velocity is like number of requests being received by Facebook parallelly, and YouTube streaming and the Google Analytics, for example, is being hit by many websites. The third one is the variety as in the data in many forms. The problems involving complex structures such as maps, social graphs, and recommendations. So like for example, if you have a problem involving complex structures such as graph, if you want to go from one point to another, that's a problem of variety. So essentially, the data related problems come in three forms or more than one form. Actually, you could have both the problems, like I want to store the data as well as I want to process the data, as well as I want to handle many requests simultaneously. So the moment while solving any of these problems, you realize that a single computer based machines are not going to suffice, not because the computer is really powerful, but because the computer cannot handle this kind of data. There are hardware problems as well as software problems. So for example, when we are reading data from a disk, it takes long time, as well as there are physical limitations. Therefore, when you face a challenge that when you cannot handle any of these V's with your existing devices, existing systems, then you say that I need a big data tool. Maybe I'm handling big data. All right. Okay. All right. So, okay, I'll try to answer this question. So this is something that, okay. Question from Ravi is, after training your wife, yeah, in just English background, yes, in Python, how good has she become in ML, and how much time did it took? Okay. Honestly, she did not pursue the ML forward, and whatever she uses the Python for the basic works, and I like writing couple of simple programs, and I find that to be quite a big success for me. And I'm not sure if she's going forward for ML, but I'll give her a suggestion. So yes, so answer is she hasn't gone forward for that machine learning. And for machine learning, it's going to be if she wants to go, it might take her a long time because she would need foundation in maths. But again, I'm quite optimistic. All right. So thank you for the question. All right. So great. Now here is a question to all of you. Question is, how much time does it take to read 1 TB from a hard disk? This is a question to all of you. We talk about we have got this much storage, we got this much hard disk, but my question is, what do you think the time it would take to read 1 TB from disk? Okay. So Abdul's suggestion is it depends on the RAM. Let's say I don't want to retain anything in RAM. I'll just read it and discard it. I just want to find a particular keyword in the whole hard disk. So do I need to retain everything in RAM? Will it depend on the RAM? Will it depend on the CPU? Will it depend on the hard disk? Will it depend on let's say uh, will it depend on which hard disk do we buy? Or will it depend on the cable that's connecting the disk to my motherboard? Good question, Prasoon. What is the seek time? That's the right question to ask, and depends on I/O channel. That's right. So my suggestion to you is, let assume a very good hard disk. Okay, not the solid state. We're talking about the hard disk. Okay, assume a good hard disk, and it's a single computer, Ananda. It's good that you answered with multiple nodes. Good. So we're talking about a single computer. Good. So yes, anybody who has answered in hours, completely okay. It could take 1 to 10 hours. Depends on the kind of hardware are you using. Okay. So the thing is, the important part here is that the important part to learn here is that when we are reading data from hard disk, it is not dependent on your CPU. The biggest bottleneck is the hard disk read speed. That's the first thing I learned. Second thing is, second thing is that I assumed that 1 terabyte is a small data and I should be able to read it quickly, but no, 6 hours is a big time. So, and when the data is being read from the hard disk, your other resources of computer like CPU, RAM, and everything remains kind of free if we are not retaining anything in memory. All right. So we could utilize that to parallel process. And this was a very important question for me when when long back I realized that okay, it takes a long time to read from a hard disk. In the meantime, we could do other things on the computer. All right, and that's the hardest concept that you will learn in case of Spark. That how do you estimate, given a program, how do you estimate what all can we parallelize and how much time it's going to take overall? Okay, so distributed computing is also part of something called parallel computing. Parallel computing is divided the work between computers or processors. Okay, so we learn all of that as part of this course. All right, now I have a simple question to all of you. Imagine you have 1 petabyte of data coming in every day and somehow you are able to store on a system. My question is, can you do it on a normal computer? Can you Can you just count the vowels in 1 petabyte data every day on a single computer? Okay, my question is, if you have to count just the vowels in 1 petabyte data every day, do you need distributed system? All right, Nikhil, was I able to answer your question? You have raised the hand. All right, thank you. Great set of questions. Keep the questions and answers coming in. That's the only way to learn. All right. So yes, because most of the systems cannot handle 1 petabyte data every day. First, to store 1 petabyte data on a one machine, it's impossible. It'll be on a network computer. Second, to be able to read at one machine, to be able to read 1 petabyte data on one machine, it's going to take a long time. Therefore, 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 1 petabyte data is big data, and we require many computers simultaneously to be able to do very simple tasks, even even very simple tasks on one petabyte data. All right. So yes, most of the existing systems cannot handle 1 petabyte data. Right. This is the standard graph which shows that big data, how big data has evolved, or how data has exploded. So you can see that the here this part is analog storage like paper clip and analog videotapes and so on, and this one is the digital storage. Digital storage is like portable media, flash, hard disk, CDs, Blu-ray, and everything. So what you see here is suddenly around 2002, the data explosion started, right? So suddenly the sales of these devices started increasing, and that's how this was estimated that the that this kind of data is being stored globally. Okay, so here something happened around 2002 that was called the beginning of the digital age. While the analog storage kept on shrinking, while digital storage kept on increasing.
Now, what happened in 2002 that caused this tsunami of data, right? One is devices, other is connectivity. And when you got devices and connectivity, the applications evolved. A lot of new applications come in that utilize the devices and connectivity. The phone that you use right now, the phone that you is in your hand right now, that phone is more powerful than the supercomputers of 2002, the phone that you are using to play Angry Bird or Fruit Ninja, right? That phone is has become cheaper, faster, and smaller as the day passed. Almost every device, whether it's your computer, whether it's your sensor, whether it's your watch, or whether it's anything, most of the devices have become cheaper, faster, and smaller. If you talk to anybody who is a hardware manufacturer, you will come to know that those three are the main agendas or main performance indicators, key performance indicators when it comes to manufacturing. So on one hand, devices became cheaper, faster, and smaller, and connectivity became more and more present, and connectivity became faster. You have Wi-Fi today, 4G, GPS, NFC, and so on, and Bluetooth, of course. So we have got all kinds of connectivity. Therefore, by the combination of devices and connectivity, we got many applications of it. And that's why there's a lot of data. When you think of device, this device has camera, sensors, and so on, sound and SIM card and everything. So this device, you can think of it like a data generator. While like you keep on liking this or keep on browsing this, all of that is generating data. So you can think of device as generating data, and connectivity is multiplying the data, right? Because people are connected and they are sharing things and so on. Therefore, the data explosion happened because of these reasons. All right. The applications, of course, had there been no application and no such kind of scale, nothing could have happened. All right. So when we talk about computer, I'm just going into very basics. To process the data and store the data, we generally need four things. When you think about computer, these are the four things that you think about. One is the CPU. CPU is something that reads the instruction from disk or the memory and then executes it. What does it mean by executing? Meaning if the instruction says read this data from here or go to this particular line, it does that. Okay, so that's CPU. The number of instructions that it can handle is called is the measure of how fast is CPU. So we have gigahertz of CPUs which can handle the gigabytes of data. Then we have the RAM. RAM is basically something that keeps the data in the memory so that CPU can quickly read it. CPU, if because CPU needs to read the data really quickly, and if it can't read the data quickly or using the random access memory, then it'll take a lot of time. So faster the RAM is, better, happier is the CPU. Bigger is the RAM, happier is the CPU. So that's a measure of the speed. Now, the third component, which is important when we talk about processing and the data, is hard disk or the permanent storage, because RAM, the data in the RAM disappears the moment you turn off the computer, right? And the ability of RAM is that you can quickly modify the data and access the data very quickly. The only downside of RAM is if the computer is turned off, the data is gone, right? Therefore, you need a separate permanent storage. And that's what is fulfilled by either using a magnetic device such as hard disk or using a solid state drive. So you basically, the permanent storage is generally characterized by disk size and the speed, right? And the fourth component that kind of goes unnoticed is the network. All right. So when the data grows bigger, that you can't fit in the RAM, you try to paste it or keep it in the disk. If the data can't fit in the disk, we kind of put it in the network. And that point of time, your network becomes important. Okay. Also, when you today, whenever you're doing processing, almost everything requires network, right? So basically, all four of these things are integral part of a computer, right? Earlier, long back, the permanent hard disk was not considered as part of the computer. All right, there was a separate card system in which you would punch things and you'll keep that. Okay, before the hard disks came into play, right? In the similar way, we never considered network, but now today, as we stand, the network, whether wireless or wired, is a part of the computer. Okay, we may live without the camera, we may live without other sensors, but living without network on a computer is really, really hard. Okay, now when we talk about big data, any of these or at least one of these components are going to become bottleneck. And that's when you'll say that, hey, I'm not able to get my work done using either optimizing RAM, optimizing CPU, or optimizing all of these. Even then, I'm not able to get it through a single computer. Therefore, we need to distribute the work on multiple computers, and that's where we need to use the big data tools. So when you have multiple computers and you want to distribute the work, at that point of time, it's better that we use the off-shelf tools such as Hadoop or Spark in order to process big data. All right. A quick question to you, if you will, just to check if you are listening to me. So quick question to all of you. Which of these components impact the speed of computing? CPU, memory read speed or memory size, disk size, network speed, or all of them? Great, great. Wonderful set of answers. So all of these impact the speed of computing. All right, Terence, is that right? Terence Nibarke. Thank you. Great, great. So all of these above impact the speed of computing. Great. Now we talked about what is big data, why the big data is a problem. Now let's talk about why do we need it, right? So my question is, let us say that you want to give a recommendation to people. Let's say you have this e-commerce website, wonderful website, and what you want to give is you want to give the recommendations to people saying people who bought this item also bought these, right? Or where this with this, right? My question to all of you is, if you have to build such a system, the performance of such a system will be better if we have big data or small data. Will this system of recommendation give you better result when you have lot of customers with lot of purchase history? Or will this system work great if we have no history of customers and we are just creating this list based on the experts? So big data or the experts creating the list, right? Thank you. So we need the history of customers. More the customers, more purchase history, better will be the recommendations, right? Otherwise, what would happen is if we are just taking the expert advice, right? Expert might not know exactly the behavior of the user, right? If they don't have the history of users. So either they conduct their surveys, go door to door, asking for people that, hey, what are the things that you bought? Again, when you conduct that survey on a large scale, that becomes a big data problem, right? So recommendations is such an example that gave return on investment on big data, meaning around there was around 40% increase in the sales at Amazon. I worked at Amazon, so this is internal, something that we got to know. About 40% increase in the sales when we started giving great recommendations. So the things that look like earlier, we were just sending an email giving our, in the beginning when we had no data, we were just sending an email about these are the new products, these are the great products, these are the discounts and so on. So we were just sending those emails. People were finding those emails annoying, right? And and the moment we started sending these recommendations as well as started showing the recommendation on the website, there was approximately 40% increase in the sales. All right, so that's a huge number if you include both website and the email effect. So, so recommendations is one such thing that put Amazon at the place where it is. The second thing which made Amazon successful is being able to hand humongous traffic, the velocity part. That is something that Amazon did really great. So basically, it is the big data that made most of the e-commerce companies successful. A question from Srikanth is, who was the first e-commerce company to put recommendation? Was it Amazon or somebody else? So there were all kinds of companies. Probably recommendation was one such feature that was there in everybody's agenda. But most of them did either based on short surveys or instincts or purchase history of some few weeks or few customers. But Amazon was able to put it on large scale, all right, large scale and entirely organic without any advertising. That was something that Amazon did, and and Amazon was able to pull it through really well. The other company who did really well at recommendation was Netflix. Netflix came up with $1 million prize for generating the recommendations, though that algorithm is not used, but there was a team who won that $1 million prize. And Netflix also ex exhaustively, or you can say aggressively, uses the user behavior to improve the other users uh, experience. So by giving recommendations and so on. And Netflix has got similar kind of recommendations as Amazon. So those are the examples of recommendations. Now I'm going to go a tiny bit of technical so that at least you don't find this as just too much of theory and nothing of practical. So I'm just going to give you a very simple example of recommendations that is generally done in industry. Let's take a look at this example. So people these days, if you, let's say you are planning to build a recommendation just like Amazon or Netflix, it's not $1 million challenge for you as it was for Netflix or Amazon at that point of time. Good news is all the algorithms are open source, are available for free. You can right away start the recommendations, right? So this is the first thing that people in big data crack is the recommendations. And my first project on Hadoop was exactly the recommendations. So today, if you have, let's say, Spark, all you need is you need to format your data in the form of user ID, movie ID, and let's say rating. Instead of movie ID, it could be any other product. Here, though I'm showing you the strings like names, but in reality, it'll be numbers like a big number, big integer here, and the ratings, all right? Or big identification. So anything is okay. So here, say you prepared this rating out of 5 of your user ID and product ID, and then you feed it to Spark, and Spark would generate you the user ID and the movie suggestions or product suggestions. All right. So this is a common format, and you'll be amazed to know that how simple it is. Just off the shelf piece of code. The bigger part is given the unstructured data, how would you come up with this table? This is where the entire engineering lies. Given the unstructured data, how would you come up with this kind of 3-column format? This is exactly what I talked about, converting unstructured data to structured data in order to generate great set of recommendations. All right. So basically, this is the example of recommendations. All right. So this, I hope this is clear to everyone. Yes. So how it's doing is it's trying to figure out which users are similar to each other and then giving them cross recommendations. That's the simplest form of doing it. Although there are many complex versions of the same thing, specifically the one that won the Netflix prize is actually quite complex and it's very interesting. I do cover that in case of machine learning, and I'm planning to go into more details this time. So that one is a little too complex, but here I'm talking about a very simple example whereby what we do is we compare the users versus users. How much similar are the users? If they are similar, start giving them recommendations. So that's the idea behind the recommendations. All right. So now the next question is next thing, very important part is that use case is the A/B testing. A/B testing is A versus B, control versus treatment. The terminology comes from the medical tests, right? What do you call them? The the test where you have a new medicine and then you test it on various patients. Sometimes even the patients don't know, and sometimes even the doctors don't know whether the medicine is a real medicine or it's just water. Okay, so that's called blind testing, and the A/B testing as a science has been developed in the pharmacology, where you have a lot of the control and versus treatment comparison. So the same thing came into play in e-commerce. At Amazon, if you just open two browsers, both in incognito mode, open Amazon.com and take a look at the two detail pages, the page where you do the buying. You'll notice that the two pages are different, right? So Amazon, you'll notice the tiny bit of differences here and there. So Amazon or any company, for example, Google, Facebook, or anybody, is conducting these tests, figuring out which component or which feature which feature is more useful to the user by the reaction of the user, whether showing the video above gives more clicks or showing video below gives more clicks. So this is called A/B testing. Imagine that there is a conflict in a team and somebody says, hey, I want to keep header as a red color. Other one says green color. So instead of getting into the personal choices, you come up with the idea that, hey, let's just launch both the variations. On the website, 50% visitors will see the variation A and 50% visitors will see the variation B. And imagine that the variation A got you 23% conversions, meaning if total 100 people came, then you got 23 sales. And if total 100 people were shown the variation B, you got 11 people buying from variation B. In your opinion, which variation, this one or this one, will you choose? Yes? Red, right? Correct. The buy now button that you see at Amazon is a result of the color is the result of aggressive A/B testing that we did. All right. It has kind of the green color, the color that you see at Amazon in case of buy now, that's kind of standard. We have tested it multiple times, and every time we found that that button is more visible. All right. So and good news is that these kind of things you can also take inspiration. If you're making an e-commerce website, you can just use that. You can use a similar format because because they have already done a lot of testing. So now, so this is called A/B testing, A/B, comparing two variations, A and B. At Amazon, we used to call it Web Lab. Elsewhere, it's called control versus treatment, and so on. So this is the way we this is the way we essentially compare the performance of various components and so on. A question was there, will there be a difference in pricing also? Good question. So at Amazon, we never do the difference in prices in A/B testing, because that's kind of unethical, and therefore we never did that. Instead, at Amazon, the idea was to keep the price as low as possible. Also, the color of the price, the way we display it, that has been experimented with, and after all kinds of variations, we have figured out that if the color, the font, the the color, the font, the way of displaying it, strike it off, and so on, that has been experimented and has been, you know, it has already been tested and solved, okay, with the A/B testing. But the price difference we avoid as much as possible. Instead, we focus on, at Amazon, we focused on bringing down the price as much as possible. Everybody should see the lowest possible price, because we know that people would buy if the price is low. Okay, that's kind of the philosophy. Okay, there are sellers website which show that's up to the sellers. Okay, but anyway, that's something Amazon should answer. And yeah. All right. Now, there are many companies around the world who are big data customers other than e-commerce, such as government for fraud detection, doing cybersecurity welfare, doing the justice, and so on. And there are telecom communication companies who do the customer churn prevention, customer churn, right? Prevent the customer, right? And the network performance optimization, and and then there are companies which, right, most of the telecom, in case of government, telecom, every data is big data. Therefore, almost every problem is big data problem. So for example, one of the consulting projects I was doing earlier was that their towers, they were maintaining the history of the configuration of every tower across the country, right? And I thought that it's not a big deal, but when I looked at individual configuration file, individual configuration file was in hundreds of gigabytes. Okay, so at the scale of telecom, almost everything is big data. So whether it's customer churn prevention, or meaning avo- stopping or figuring out, preventing the customers from leaving you by providing the better service, or figuring out your problems, uh, figuring out the problems in the system in order to avoid users leaving you. Then network performance optimization, like traffic management across the network, as well as the calling record data analysis and analyzing the network to predict failure. The fourth one was one of the problems that came recently to me, where they wanted to predict whether the equipment fails or not upfront. All right. Now, the next industry that uses big data is healthcare and life sciences. Almost everything in healthcare, again, is big data. Big data is in humongous data that you can't handle on a single machine, whether it's health information exchange, gene sequencing, drug care improvements, or drug safety. Now, there are many solutions to big data. We'll start from here after the break. Let's take a break for 10 minutes. Okay, let's take a break for 10 minutes, and we'll continue after 9:42 p.m. IST. Please feel free to post the time in your own time zone. Break for 10 minutes, back by 9:42 p.m. IST. Please post the time in your time zone in the chat window. All right, so I'm back. Should we start now? Yes? Great, great. All right, so wonderful to have all of you in the session. for a wonderful set of questions and answering and engaging. And I learn every time I conduct any session, and I learn from all of you. All right. So feel free to ask questions and try to answer the other people's questions as well. And the only thing that you learn is the one where you either ask questions, do hands-on, or apply practically. All right. Otherwise, most of the things that you don't use or don't ask questions about, you will kind of forget. All right. So, I mean, we have done the experimentation and I mean, the A/B analytics, as you can say that, and we figured out that asking questions is probably the only way to learn new things. All right. Great. Thank you, Prasoon. Let's move ahead. So, yes. Okay. So, what happened to this one? Wonderful. All right. I hope my voice is clear and you're able to make out from my words and accent. All right. So let's get started. Now, we talked about what is big data, why big data became important. We also talked about the various applications quickly. In general, you will be able to figure out by now that wherever the data has grown beyond a certain limit, everywhere you would require distributed computing, and hence big data tools will be needed, right? Because big data tools are nothing but the tools that make you do things using many computers, right? If what happened to the internet? Okay, so if we had all right, let me rephrase. So wherever the the data has grown beyond a certain size, you would require multiple computers to solve it. And to get multiple computers to work on your problem, you either need to write your own system or you can use an existing software. And there are many software to get the work done. And here are some of the examples. The first one is the biggest stack that is used around the world. That one is Apache Hadoop with Spark, right? That's the case where you want to set up your own server and own ecosystem. In those cases, setting up your own Hadoop and Spark makes sense. But sometimes you may not want to set up your own cluster. In those cases, you may want to go with AWS or Google Compute Engine. They provide you huge storage as well as computing on the cloud. But in many cases, either this is too costly for your use case, or it is something that your company or your organization may not agree to, because this requires you to sending the data from your organization to Google Compute or AWS. The third bucket is other than the Hadoop and Spark ecosystem, the other kind of softwares that are there are Cassandra and MongoDB. These are great kind of data store. I would not call them database. I'll call them data stores, and such data stores are called NoSQL. And NoSQL data stores are nothing but databases using multiple computers. All right, databases using multiple computers, and not databases, actually data stores where you store kind of structured or semi-structured data at these places and do the computing. But again, Cassandra and MongoDB have their own limitations. So the most common preference across the globe when you want to manage your own big data ecosystem, the most common choice is Hadoop and Spark. Hadoop and Spark and Hadoop and Spark, Cassandra and MongoDB, all of these are open source. Hadoop is open source and the license is Apache. What is Apache? Apache is nothing but Apache started as a server, the web server. Almost everybody either use Apache or IAS from Microsoft. And The Apache is most common, along with a cousin brother called Nginx. That's what people use with Apache. So Apache was used to be a server, then it became such a big umbrella, it became the de facto standard for most of the open source. So Apache, as of today, is a license as well. So if you have an open source software and you want to make it, you want to take up Apache umbrella, you can apply there and they will incubate and see if it can happen. Similarly, Hadoop and Spark both are under the Apache umbrella. Now, after Hadoop became really popular, the other projects came under the umbrella of Hadoop. All right. So what is Hadoop? Hadoop was created long back by dog cutting in 2011 or so. 2000, not 11, I think 9 or 10. And it was built for, they were building their own search engine called Nudge. He was joined by Mike Caffarella, and they were trying to build Nut search engine, but they were stuck. They were kind of not able to move ahead because they realized that if they want to build a search engine as big as Google, you need to have a storage to store humongous data. Similarly, you need to have the capacity or ability to process such humongous data. And that's when Google published these three papers: Google File System, Google MapReduce, and Google Bigtable. And on those lines, they wrote the first version of Hadoop. And afterwards, they did a lot of innovation. Hadoop team did a lot of innovations. And there are a lot of tools as of today under the umbrella of Hadoop. It started with three things: a file system, MapReduce processing, and a Bigtable. So those were, the Bigtable is nothing but a kind of data store, a kind of a tabular storage, because file system stores only files and folders. So you can't store, if you have to modify cells and you have to modify columns and so on, you can't do that on a file system, right? Therefore, there was a need of a Bigtable. So Bigtable became HBase, Google File System became HDFS, and Google MapReduce was Hadoop MapReduce. So it was named as Hadoop after a toy elephant, and the license, it's an open source license and Apache. Probably that's one of the reasons why Hadoop is successful, because it has such a liberal license that you want to use it for free or commercial purposes, you don't have to pay to anybody. All right. Now, question is, why do we need to buy, say, Cloudera or Hortonworks? There are two companies who basically provide support around Hadoop. If you are looking for a supported version whereby there will be a company supporting and helping you solve the issues that if they arise in production, then you can either go with Hortonworks, Horton, Hortonworks, or Cloudera. Those are the two common companies, and then there are smaller companies like Qbol and so on. Though they also provide the support around Hadoop. So essentially, Hadoop is an open source, and that to Apache, and it's quite powerful, popular, and well supported, right? So it's a framework to handle big data. It helps you in handling humongous data, right? And it started as like three software, but now as of today, it has huge list of softwares. And under the umbrella, all the softwares have three qualities. All the softwares are distributed, meaning they run on many computers simultaneously. Scalable, meaning in case today we need 5 machines, it should be able to get the work done using 5 machines. And tomorrow, if we need to increase a couple of machines, that should not be a problem. That's called scalable. Third is reliable, as in some of the machines go dead. In those cases also, Hadoop should be able to handle, or any of the umbrella components should be able to handle the failure of the hardware. So that's why reliable computing. Now, most of the components are written in Java, and that used to be the criteria, but all of these components can be used from any programming language. All right, so this is a quick ecosystem. I'm going to go through this ecosystem really quickly. If you have more doubts, please feel free to ask. All right, and then I'll move on to say Spark, and then we'll continue from there. So the first thing and the most important thing is a file storage. So when you want to build any system, the first and foremost thing that you rely upon is a file system. What is a file system? When you open your My Computer in case of Windows, you see C colon, and inside C colon you have My Documents and you have the folders. That is the file system, right? File system is a system where you can store the data in the form of files and folders. Okay, so Hadoop provided you Hadoop. The first component that they wrote was a file system, or HDFS, Hadoop Distributed File System. Now, why was there a need of such a file system? Because we could not store data using one computer. Therefore, we needed a file system which could divide the data on multiple machines and thereby utilize the hardware provided by each of the components, each of the computers, in order to provide a singular storage, so that user does not have to worry about my file is on A computer or my file is on B computer. User is abstracted. User is this whole thing is encapsulated under the HDFS. From the end user perspective, HDFS is just like a folder structure. So I would like to show you right away how does the HDFS looks like, so that we have a visual recall of what we are talking about. All right. So let me show you the. Okay. So let me take it to full screen, and in the parallel, I will open the. All right. If you log into CloudX Lab, if you already have, let's say, account at CloudX Lab, so if you don't have the account with CloudX Lab, you can generally just sign up for free, start free trial, and then you'll get the access to the lab. And afterwards, you can just go to My Lab, click on the user icon, and you'll go to the My Lab. Here are my credentials. So here, these are the various Hadoop services: Ambari, Hue, and Web Console, and Jupyter. Ambari is the tool that is provided by Hortonworks. What does this tool help you? This tool lets you install and manage the Hadoop and other like components like Spark and so on. So Ambari helps you install and manage the components. Hue gives you a very good interface to interact with all of these tools. Okay, so before jumping further, let me just show you how does the cluster look like to you. All of the components that you have just seen the glimpse of, right? These components, all of these components are stored already for you. So since these services are, as I was telling you, the HDFS that you talked about, it is running on multiple machines. Okay, it is running on multiple machines. So it says that it is running on six out of 7, right? You can see one is dead, that it is still able to handle the work. Okay, so this is HDFS. HDFS is running on multiple computers happily, right? Let's take a look at how does the HDFS looks like. So this is Ambari view. Ambari gives you a way to, let's say, restart, stop, and so on. I don't want to touch it right now. So you can control all the services. So, and the second one is Hue. Hue is another component to interact with Hadoop by Cloudera. This one is from Hortonworks, and you can, okay, they don't have given that Hortonworks name anywhere. All right. Okay, never mind. So here you can see Hue. When you click on Hue, it's going to open like this. And in there, if you click on File Browser, you'll be able to see the file browser. This is HDFS. For you, this might look like I have too many files and you don't, because this is your space, because I've been working on CloudX Lab for quite some time, and I've worked on some projects here and there. So my files are there. For you, might be empty folder. All right. So this is the HDFS. HDFS is just like any other file system. You can create a folder, but in only in your folder. This is my home drive /user/Sandeep Giri 9034. This is my home drive in HDFS. HDFS is a file system that's running on top of many computers. And here you can see clearly that you don't have to haggle with the multiple computers. So it could be that this file is stored on some set of computers. This file is stored on this folder is stored on the files inside this might be stored on another computers and so on. So basically all the complexity of distributing work or data on many computers is hidden from the user and is behind HDFS. Okay, so not only the users, but other applications also use HDFS for storing their data. All right, so I'll just show you that this is where we store the common data sets. If you are trying to process some data, you can use this folder. This is a read-only folder for you. All right, so this is the HDFS. In HDFS, your home drive is, everybody is given a username. When you sign up with CloudX Lab, you'll get your own username. And you can see that the home drive for everybody starts with /user and then followed by the login name. All right, so this is the HDFS. I hope it is clear. You can create a folder and you can create a file. Yes, go ahead, Suresh. A question is, can we see those files? You may not have access to my folder unless I have given. Let me just see. I have given to everybody, so you can actually go to my folder and take a look at them. Okay, so these files have the permissions and everything. I'm not sure if you can change. Oh, there is a folder. There is a way to change permissions here. You can also do that for the folders. All right, I have given you the access to this. So you can click on the edit button there and put this username, this URL there. If you are okay, and you will be able to see my files. All right, my file, there is nothing confidential here. Everything is shared with the learners. So that's why I have given the permission to read or open my folder, so that in case somebody needs to, let's say I want to coordinate with you, you can take a look at my files. Similarly, I have a data folder here where we have kept the common data sets, which is again accessible to everybody. All right, a question from Suresh is, question from Suresh is, this file, how can I see which node it is stored? Good question. So there is a command called HDFS followed by FSCK. Okay, that you can use in order to see which all machines are holding parts of the data from this file. Okay, because these files are broken into pieces and distributed in the network in on the computers. All right, great questions. Now, question from Srikanth is, how do we execute these commands in Hue? All right, again, good question. The third component here that you see is Web Console. You can click on Web Console, copy paste the password from here. You can just use this copy button. Okay, so I'm just copy pasting my login password. All right, so this is the standard Unix console. From here, the way we were talking to file system, from here we can also talk to almost every service from the console. All right, almost every service from the console. For example, let's say I want to talk to Hadoop file system. I can use a command called Hadoop FS. Okay, and here are the sub commands of Hadoop FS. Take a look at those and you can interact with those files. Those who are not comfortable with command line, they may be not finding it comfortable, but my strong advice is be comfortable with Linux if you want to succeed in the data world. All right, because most of the commands, most of the Unix system has been designed to handle larger data. and the filtering system and so on. There is a lot of things that you can use out of the box in case of Linux in order to process humongous data. All right, so here you can see that I'm using this simple command to take a look at list of the files. All right, so you can use this kind of tool. All right, I hope that I was able to answer your question. Don't worry in case you're finding it too scary. My suggestion here would be once you sign up, there are these links. Take a look at these links. Okay, and this is the important part. You should take a look at that, and also take a look at our what do you say? Here there are chapters here. Okay, there are chapters here. If you scroll down here, you will find a lot of things to just get started. Say, for example, Linux basic tutorial. This is our Linux tutorial, so you can take a look at that. Also here, whatever you are performing is actually your social profile. So for me, this is my social profile. You can take a look at this. Okay, so all right, this is going to help everyone who is performing various actions on CloudXLab and is going to be a representative. So here, this is like, what are the courses I'm enrolled to, the topics I've completed so far, and so on. This is my profile, right? This is CloudX Lab strictly, the ideas that we're working on. So you can take a look at the Linux basics. It has around 27 concepts, 33 questions, and 27 assessments. And there are approximately 1,500 learners. And so take a look at that. And so this is going to be quite useful to you. All right, and when you start now, then it'll automatically show you the console on the right hand side and the text on the left hand side. Okay, so you could just in case you don't find it comfortable, the sizes, you can generally resize it. And you can keep on switching between various questions and then take a look at, let's say, here is a challenge where it asks you to copy files and so on. So you can take a look at the CloudX Lab and use it. And this is definitely going to be probably the easiest way to do practical learning on Linux. All right, so feel free to use the web, get yourself comfortable with the console, all the commands and so on. All right, great set of questions. And make sure that so I'm not going to be trying to um, make you happy by telling that without Linux you can do everything. No, my suggestion is, if you want to be engineer, we want to stay in an engineering kind of a role, data engineer, or even if you want to be a good data analyst, make yourself comfortable with Linux. All right, why? There are other reason is, even Windows is going to provide Linux with the normal Windows, Linux console along with that. A question from Srikanth is, will it look at AWS and GCP? So your Hadoop programs that you write will remain same, but Ambari may not be there, but now they have integrated Ambari on AWS. So, okay, by default, it'll be a little different. All right, there are two questions that I would love to answer. And let me go back here. So we talked about how to see the file system. Now we can continue with other components. Before that, I'd like to answer a couple of questions. A question from Ravi is, if the file is distributed, then failures occur in one, you lose that section of files. Good question. So I will strongly suggest that come over to CloudX Lab, take a look at, say, here, there is a chapter called HDFS. You attend this chapter and your doubts related to the HDFS will be cleared there. All right. A question from Robin is, what components of Hadoop distributed file system can handle app, code, and data for peer-to-peer web hosting distribution, such as those which can be applied to blockchain? Or is it another Hadoop ecosystem component which can handle those? All right, good question, good question. That's something that I'm coming to next. All right, so Essentially, when you think about the B2P peer-to-peer applications such as blockchain, most of these tools have not been designed for that. But you have a wonderful tool like Yarn. You can actually write, you can actually write your your application, which can parallelly do the peer-to-peer the distribution of work. You can definitely use just the Yarn and do that, use that in order to do the computing. All right. So you might have to build one because I don't think there is another out of the box component for doing the same thing. Okay. For that, you might need to use Ethereum or blockchain or something and put it onto Yarn. Okay. So also Yarn is generally installed by us and is generally installed in the data center, unlike most of the protocol that we are talking about, peer-to-peer one, where every user across the internet installs those frameworks. All right. So we talked about a very important component called a file storage. We looked at the file storage basics and so on. All right. Satish, did you have a question? There's a dot in the question. All right. Crystal, you have a question. You have raised a hand. All right, great, great. So those who are the already enrolled users with Big Data with Scala, and they can this is basically an introductory public session for all. From the second session onwards, it'll be a small group of people, and we don't generally go beyond, say, 25 users in a class. So you won't have these many people in the class. This one is a public because these technologies, the introduction is needed by product managers, engineering managers, the analysts, and everybody. Everybody wants to at least know the basics of it so that they can pursue the career further. All right. So that's why these sessions are kept public for everybody. All right. Now, okay. Another component is Yarn. Yarn is for computation. While on one hand, HDFS is for storage, Yarn is for computation. Yarn is something that runs the programs. Okay, to take a look at the Yarn, Yarn is not something that you work with, because Yarn is like an operating system that you use through other applications. Okay, so the only thing that you could take a look at is probably job browser. Job browser shows that the jobs that are running on top of Yarn, these are my jobs that ran on top of Yarn. Okay, so Yarn is like an operating system which can execute any program in the network. Now, what kind of programs? MapReduce or Spark on any other things. So Yarn is yet another resource negotiator. All right, but that is basically to manage the network resource, execute any program you want, and so on, so on. Then on top of Yarn, because Yarn is just too complex to use for end user, we either use a component like MapReduce or we use a component like Spark. So on one hand, we have Yarn. Yarn is something like operating system. Like when we are using right now the internet, we are using Chrome, right? And Chrome is running on top of operating system. Similarly, we generally use MapReduce or higher level work like Spark or other things in order to do our computation instead of Yarn. So the other computation framework is MapReduce. MapReduce, just like MapReduce, we have Spark. Spark is essentially a computation framework in which, meaning we write our logic in a programming language, compile it, bundle it together. Either we give it to Spark or we have written it for MapReduce. So if we have written for MapReduce, we'll give it to MapReduce. So we hand over our piece of package to MapReduce or Spark and let them execute in the network. And they will, of course, utilize yarn. They will order yarn that, hey, we want to execute this program, please execute it on many computers, and so on. So that's where the interaction between MapReduce, Spark, and yarn comes into play. MapReduce and Spark are competitors, all right, and Spark is replacing MapReduce in many use cases, and a lot of computing has shifted from MapReduce to Spark. The other component is EdgeSpace. EdgeSpace is a NoSQL historian. You can't really store data in the files. Like, for example, you want to do tailor manipulations. In those cases, you don't want to just use the file system, because in file system, if you modify a single line, you have to rewrite the whole file. Correct? Therefore, file system is not of great use if you have to delete few lines, edit few lines, change few cells, and so on. Therefore, you need a database kind of system called EdgeBase. EdgeBase stores data on the file system internally, and you can process the data using Hive, MapReduce, or Yarn in HBase. Now, the next thing is Hive. Hive, since for every work, you don't really keep on writing the code. Therefore, for if your data is in kind of a structured format, you would like to do the processing using Hive. So Hive uses Hive converts the query into MapReduce logic. MapReduce logic gets executed on top of Yarn. So that's the way it is. Similarly, Pig is no longer used much, and Pig was similar to Hive, in which you give the SQL kind of format and it will run it on top of MapReduce and so on. So then there was something Mahat. Mahat was basically machine learning library, but all of this has been replaced with Spark. Then Uzi, when you have a larger project, so you might be using you might be doing some operations on HDFS, you might be doing some operations on MapReduce, some HBase, some Hive, some Spark, and so on. So you will have the entire workflow of applications. And in those cases, you will need a tool like Uzi. The other tools that we haven't mentioned here is Flume and Scoop. Flume helps us to process unstructured data, not process, transport unstructured data. Let's say you have a lot of files coming up every minute and you want to push them continuously into a central storage. Then you use Flume. Or if you have, let's say, the scoop is used to pull the data from your structured sources such as SQL into the HDFS or HBase. Okay, so if you have like existing database and you want to transport the data to Hadoop system, you use Scoop. Let me take a look at the Uzi use case. Let's say that we have a recommendation system using Flume. We transported data to HDFS. Then maybe Pig. Using Pig, we converted the data into some formats, and using Spark ML we generated the recommendations and again saved it to HDFS. And then using Scoop, we transported this data from Hadoop to your existing database, and from there the web server took the recommendations and started showing on the website. So if you have to build an e-commerce recommendation, probably this is the flow you are going to use. So using Flume, you'll continuously copy the logs to HDFS, and from there you will use an analytics tool or ETL tool to convert it into a meaningful format, a tabular format, and then you feed that to MLlib, and then you basically once you have generated the recommendations, you will copy the recommendations using Scoop into the MySQL server or any other database servers. From there, your web server will pick it and show it. So these are the steps that you will take, and this is where Uzi comes into play. All right. Now, before I jump into Spark, I would like to address your questions very quickly. I'll be answering using Q&A window. Please ask the question using Q&A window. It'll be very useful to me. It'll be very helpful to me. A question from Robin. Will Yarn be compatible to function with coding components such as Ethereum, Solidity, and JavaScript? It should be, but it'll be, I would say that it'll be overkill, because Yarn was designed to handle, say, thousands or 10,000s of nodes, not lakhs of you. nodes or not millions of nodes. Okay, so but it is definitely possible to the you directly manipulate the program, you directly execute the program using yarn. All right, it is definitely possible, but it'll be just too much of overkill. Okay, a question from Raju is in a cluster which actually yarn be set up, in a cluster where actually yarn be set up, does it sit separately on a separate node, other name node? Or no, actually you generally install the components on various machines parallelly. Okay, so um, it is possible to set up all these components on a single machine, but because of the load concerns, when name node is a very critical node and so on, there are various nodes, and there you generally divide the work. All right, so I would suggest that you should take a look at the installation video in our blog, where we have gone through in detail about how to set up your own cluster. All right, something on the lines of CloudX Lab, you can also set up, but it'll cost you a bit money. All right. So yes, so you could use the blog that we have created already. A question from Terence is that when you install Hadoop on a new computer, can you copy an old HDFS files to new? Yes, using Hadoop. There is a command called Hadoop. I'll show you. I kind of, if you go to, there is a distcp command, so you can use distcp, D-I-S-T-C-P, Hadoop distcp command to copy one HDFS to another. All right, when you use MapReduce in Spark, when to use MapReduce in Spark as best practice. So my suggestion is that anything that can be done with MapReduce can be done with Spark. And I would suggest, is my honest suggestion, that you basically use Spark. There's no need to actually go with Hadoop right now. All right, only in the case where you may be having like some petabyte data and you really want to ensure that memory is not consumed. In those cases, you may want to go with MapReduce. Generally, MapReduce is used as a backward compatibility, meaning you already have a code which is running on Hadoop MapReduce, and instead of revamping it and writing it for Hadoop Spark, you basically just maintain that. A question is, so is HBase parallel to HDFS? No. So just like you have normal database, right? And where does normal database store the data? In a local file system. In the similar way, HBase stores the files in HDFS, and HBase provides you a tabular format to store data, so that in case you want to say modify a particular value, if you were storing in a file, you will rewrite the file, correct? You will delete the old file, or you will create a new file and copy entire thing. I remember doing things in file system long back when we were not allowed to use the database because we did not have the database on server. So we wrote this tiny utility to delete a particular line, and how we were doing it is by either commenting it out. We came up with an idea called commenting, or by keeping the space in the file, and so on. It was actually quite complex to handle deletion of a record or updation of a record using the file. Therefore, in the similar situation, HBase is used for record-wise operations or record-wise modifications in the data. All right. A question from Srikanth is, can you repeat last minute's? Voice was cracking a lot on my side when you started with recommendation use case. All right, I'll just walk you through this. All right. So imagine that you are an e-commerce company. Okay. Okay. Imagine that you are an e-commerce company. You have a lot of data in your server logs. What is server logs? Whenever you're requesting a website, the web server is making a note of which website are you accessing, what's your IP address, what time is it, what URL you want, and so on. So all of these details the server is making note of, so that we can do many things on top of it. So imagine that we have a lot of such servers producing web server logs. So using Flume, you will continuously pump these log files to a central place called Hadoop Distributed File System. Then from there, you will use either Spark, Pig, or Hive. Spark, Pig, or Hive. I'll just put it like that. Okay. So you will either use, all right, this one is Spark, Hive, and Pig. I have just written in the order of my personal preference. Okay. All right. So, all right. So, okay, there's something wrong. Uh, all right, never mind. So let me explain again. So, uh, all right. Yeah, I think. Okay, I think this is good enough. Sorry for doing this. All right, so let's say your web server is generating logs. From there, you copy using Flume continuously. As in when the file is being created, the Flume will copy it from the web server to a central location. And there, what you'll do is using any of the ETL tools such as Spark, Hive, or Pig, you will convert this raw data into a tabular format, data, and that too you will store back in the HDFS. Then using say a machine learning package such as Spark ML or so, you will take that table that you just created in the previous step, table as in maybe the comma separated values or so on, and you basically produce the recommendations. Then once you are done with producing recommendations, you take these recommendations and take it back to your web server. Take it back to your web server using Scoop. And web server as in the place where you are keeping your data. These recommendations can be copied from HDFS to your database. And from there, your web server can happily serve it to the end user. Of course, web server will have to, the web programmers will have to build a nice UI to display the recommendations. And then web server will read the data from MySQL and do that. Now, this portion that you see here, this portion will be executed every now and then, while the first step is happening as and when the data is coming in. This section that you see in the rectangle, this section is basically happening periodically. Every day you're generating new recommendations. In those cases, this will be done. Remember that this use case, this example basically is valid for the cases where you are okay with the recommendation being generated every day or every hour or so. This is called batch processing. All right. A question from Venkat is the HDFS scoop MySQL required on the web, or can we directly take from HDFS using other way? No, you can actually do all of this using command lines. You don't need to do it from the browser. Is the HDFS to scoop to MySQL, HDFS to scoop to MySQL? Uh, to web required to show on the web, or can we do, okay, so question is, why do we need this step, right? Why do we need this step? You can directly display the data from HDFS. Yes, you can, but in case of web server, you generally want really high speed. And in those cases, the HDFS could have a tiny bit of latency. Okay. Also, in web servers, we generally prefer the structured data, and recommendations are tiny. So it's okay to copy those into the non-distributed systems such as MySQL. All right. Is there a API mechanism to get things? Yes, SDFS does have an API. You can use that one as well. And in fact, the Hue that we saw, browser-based tool, it's using the API to display. Question from Subra is, what is the use of Spark MLlib? Spark MLlib is the brain, is the one that is doing the machine learning, is producing the recommendation. It is taking the raw data in the form of like this person, like this particular product, this much. So Spark MLlib is taking that data of the customers and producing the recommendations. All right. And you'll notice that out of all of this, the machine learning or the core part is very tiny, like 5%. Yes, ETL technologies are replaced mostly with Spark. All right, great set of questions. Keep the questions coming, and that's the purpose of this class. All right, now the next component that has that's the one that is getting the most spotlight is Spark, and there's a good reason why Spark should get a good spotlight. Why? It's a fast general engine for large-scale data processing. All right, though this sentence is grammatically correct, but it doesn't convey much to you. All right, therefore, let me go into more details. The first one is, it's basically really fast MapReduce, meaning if you want to do certain computing, like you want to find unique words, you want to do this, everything that you did in case of analytics, you can do that using Spark, using many more machines, right? If you have, let's say, 1,000 machines, 100 petabyte data, uh, or 100 terabyte data, you can happily produce any kind of results using Spark. All right. So it's kind of really fast and easy MapReduce. MapReduce was, you had to write code in Java and you have to compile it, submit it, and wait for the results and so on. But this one is extremely fast and easy to code. It builds on similar paradigm as MapReduce, and it integrates very well with Hadoop. Now here is the various component architecture or various components and how they are related to each other in Spark ecosystem. The first one is the Spark core. This core is something that takes care of entire mechanics of distributing work. So Spark core is equivalent to Hadoop MapReduce. Hadoop MapReduce has this concept called map and reduce. Spark core has a similar concept called actions and the transformations. So there are many transformations. So when you write a code, you don't write for loops. Just like in normal programming language, you will be, of course, using the standard programming languages, but your paradigm, your way of coding will change. You will be writing something in the form of map, reduce, and so on. So you will code to Spark core, and Spark core will take your code and distribute to the entire cluster. It can distribute using, say, Hadoop's yarn, the one that we just discussed. Either it can run on top of it or on top of Amazon EC2. It can also run on top of Mesos. These are all three components. This one is hosted. Yeah, Hadoop's yarn and Apache Mesos are kind of competitors. So they are basically like a distributed operating system. Now, this one, in case, let's say your company is new to it and you don't have a existing cluster manager, in those cases, you can set up the standalone cluster manager that comes with Spark. So Spark did a very, very clever job, very smart job, because instead of saying that, hey, we can run only on our kind of cluster, they said that whatever kind of cluster you have, Spark can run. All right. Now, Spark can read the data from all kinds of storages, whether your data is in HDFS, HBase, Hive, Tachyon, Cassandra. It can read the data from all these sources. Also, one thing that goes missing all the time is that it can not only read from these sources, but also when you are doing the processing, it will execute the work nearer to the data on these locations. All right. Since we know that HDFS is stored on multiple machines parallelly. So when you are storing a file in HDFS, so it can distribute the work on many computers. It can store the data on many computers. And when you are processing this data, instead of bringing this data to a central place, Spark distributes the work to nearer to the data. It will send the code, the logic that you write, nearer to the data. Instead of bringing the, let's say, wood to the X, we are taking the X to the wood. That's the difference between the traditional programming and the programming with Spark. The programming with Spark is we, whatever code we write, it is distributed to the entire network, and it'll try to be distributed nearer to the data. Instead of bringing data to the Spark, we basically distribute the code to machines which have the data nearer to the data. So that's the idea behind Spark. So Spark can read and execute the logic nearer to the data on these data sources. So now, one was like plain vanilla Spark core where you wrote maps and reduces, but that was not sufficient. It wasn't practical to do all these complex processing. Therefore, we needed a complex system such as let's say we want to process the data in the form of tables. That's where the data frames came into play. Then we wanted to process the data that is coming really fast per second, and we wanted to process as and when the data comes in. For that, there is a package called streaming. That's a part of Spark. Then third one is MLlib. MLlib is probably most powerful distributed machine learning API. Machine learning package. MLlib is very powerful when you have to do complex processing such as generating recommendations, predicting the demand, predicting, let's say, doing natural language processing, or any kind of computing. You can distribute that computing using a Spark core via MLlib. So you will write your logic utilizing MLlib's algorithms, and those algorithms will utilize the Spark core and get the work done on the entire cluster. The next one is GraphX. GraphX is again very powerful API, very powerful, not API, very powerful package. Let's say you have to process, you have to find out who is most important in the world on Twitter. So you do the graph computation, and you can do the page rank computation and so on that Twitter graph using GraphX. Okay, because graph is like I'm following you, you are following somebody else, and they're following back to me, and so there's a full graph of nodes which is being connected. So to do that kind of computing, you need a graph processing engine such as GraphX. So these are the extra libraries. These are the extra libraries on top of the core. Then the beauty is all of this can be done in any programming language, right? All of this can be done in any programming language, be it SQL, be it Spark R, be it Java, be it Python, be it Scala. So if you are good with any of these languages, you can get your work done mostly. The only difference is that SQL, in case of SQL, the harder part is that very sophisticated problems where, let's say, you are uncompressing the zipped file and so on, those kind of things you cannot handle. Similarly with SQL, only the data that is structured format, we can handle that. Therefore, so good part is we can combine all of this. Let's say some part is written in Python, and you want to utilize SQL as well. So you can take the raw data, convert it into a data frame called table, like a table structure like Excel sheet. So you can take a raw data from plain text file using Python and then convert it into table format, and then using SQL you can query that table. So you can write a project in hybrid programming languages, right? So if you have a really complex project, you can actually make it really simple by the way of using project specific or need specific programming language. So although everything can be done in any other programming language, but if you really want to, let's say, do something in R, something in MLlib, something in Python, so you can combine all of this. So all kinds of computing, whether based on SQL, based on real-time data or MLlib or graphics, you can do all kinds of things using most of the programming language. All right. So this is the most important part. So it essentially puts the debate about which programming language should I use. It puts the it silences that debate because you can do almost everything. You can do everything with every programming language on top of Spark. And that's one of the reasons why Spark got this kind of popularity. All right. A question from Satish is how Spark is faster than MapReduce as both send job to the data node. So Spark is faster because it provides you more constructs, more controls, more knobs so that you can optimize the job. Also, Spark takes the basic assumption of making things easier. Also, if you have multiple shuffling operations, you will need multiple jobs in case of MapReduce. But in case of Spark, a single job can do multiple shuffling operations. So those are the technicalities. And I have actually written a answer to this question on Quora so that you may find it useful. All right. Great questions. Great questions. Keep the questions coming, and that's the only way to learn. All right. So that's the only way to learn. So do not hesitate in asking questions, whether you are learning from me or learning from anybody else. My suggestion to every learner is ask questions. Do not worry that your question is dumb or your question is stupid. No, there's no such thing called bad question. It's only the way we look at it. And I have seen it in past that in one of my talks, there was a person who asked a question related to machine learning, and it sounded as if it's a really dumb question. But if you look at the if we when I looked at the question, I found that to be very insightful. Like question was, is it how do we trust algorithm? That was a simple question, right? It sounded really, for those who are not aware about various kinds of performance measures, various ways to, ensuring that it meets our requirement, they found the question to be bad, but I found the question to be insightful. So, and if I didn't have the knowledge about subject, I would kind of if I might try to suppress the question. So my suggestion to you is, whether you are in my class or you are learning with somebody else, make sure that you ask questions. All right, that's the only way to answer. Okay, sure. Shrikant, I would love to answer your question. By the way of, I have a video for you. I will probably, if you drop me an email, I'll reply to you with the video. You can go through the entire setup and you'll get a thorough clarity. Your question is insightful. And I would like to, because this question deserves more attention than I can give right now. Therefore, I would love to answer it in I have already created a video for you. All right. So I'll just share that one with you. Just drop me an email at Reaches. Okay. All right. Let me get back to Venkat's question. Question is, how good is Spark for batch processing? Yes, Spark is good for batch processing, except for streaming package. Everything else is batch processing, right? This streaming is again like batch program only. So you launch it and it keeps running. There are two kinds of programs. One is batch, other is streaming. Batch is the one where you run the program, it finishes the job and exits. That's called batch computing. The other one is streaming or stream processing. Streaming is like very overused term. So I'll call it stream processing, or we call that unbounded data processing, meaning there is no limit to the data. So stream processing is when the process waits for the input data, and as and when the input data is coming in, it's doing the processing and putting it in the output. So this is called stream processing, where the processing is continuous. Where processing is continuous, that's called the stream processing. All right. And okay, would like to know Spark components such as Kafka and Storm. Those are not part of Spark. Kafka is a queue like an enterprise bus or a big notice board in the company where everybody can write and everybody can read. That's Kafka. And Storm is kind of, um, if you want to do stream processing on the data that's coming at milliseconds or sub-second time, in that case, you generally use Storm. Storm is a separate component. All right. A question is, can we connect ETL tools like Talend, Informatica to Spark Streaming, another library? So connecting them to Spark Streaming may not make sense, but connecting them to, say, Spark SQL would make sense, because Spark SQL comes with a server that listens to your queries, and you can connect from Talend or Informatica or anything to represent the results, right? I hope I made sense here. I'm not sure. Informatica is a ETL tool. Okay. All right. I'm not sure actually. I think I read it like a reporting tool. So Talend and Informatica, as I saw when I looked at Talend's website, they were saying that they are compatible with Hadoop ecosystem. So they might be doing similar to what Spark does. All right. They might be, connecting directly to Hadoop and doing that work. All right. All right. I'll just can you explain Spark job distribution on cluster? Yes. So I would love to explain it in more details. It would require a full session, and we have a full session covering how does the work get distributed using Spark, because that's kind of like 2 to 3 sessions. And we work hard on understanding how to break down our logic such that that logic can be distributed to the cluster, as well as we understand how exactly the Spark distributes the work. All right. So you can you can either join me in the next session onwards, or or, or you can take up the self-paced course. All right. Or you can drop me an email or leave one discussion form. I love to answer in detail, because this one is really huge answer. Okay. Because 90% part of Spark is about that. All right. So a question from Suresh is, what's the difference between Spark Core and Spark Kafka? Kafka is not part of Spark. Kafka is basically a queue. Queue is something like a service, just like you have a database. There is a service called a queue. In queue, the data comes from one side, and listeners are given the data. So many people are listening on the queue. Whenever the data is coming in, the people are reading from or getting notified from the queue. That's the role of Kafka. Spark Core is like batch processing system. When you have big data, you want to process them. So that's about the difference. Okay. All right. How to connect Kafka and Spark Streaming Core. You can take a look at the example that we have. All right. Probably this will give you a better answer. And if you go to our, let's say, blog, okay. If you go to, say, blog here, and there would be a blog post called dashboard, right? This one is kind of de facto for the industry. Most of the people use this blog in order to build the real-time analytics dashboard. And here we talk about how to build Spark and other parts, how to build on top of Spark. All right. So a question from Robin is regarding the data sources. what is the main difference amongst HDFS, HBase, and Hive? Okay, what's the main difference between HDFS, HBase, and Hive? HDFS is for storing files and folders, and HBase is for record-wise manipulation, and Hive is mostly for analytics, though Hive has started providing updates to the data, but Hive was mostly an analytics engine. All right. Okay, a question from Venkat is, so effectively streaming is batch processing in extremely high frequency and speed. That's correct. So if you look here, this one that you see here, the streaming is nothing but an infinite loop, meaning it'll wait for the input data to come in. As in when data comes in, it launches the batch process and then again start waiting. All right. Okay. All right. A question from Pankaj is, please explain Spark job distribution on worker node. We would cover that in more details. We have 12 more minutes. Okay, because this one is a hard question and a bigger question. I would love to go into those details. Join me in the next session. I would from not next session, probably fourth session from now. Okay, that's when we will go into more details about the Spark job distribution. All right. Uh, a question from Terence is Hadoop or Spark better on Windows or Linux? Both are basically, both of them run under the hood on Java, right? It's, so when we are, okay, let me explain to you. A lot of people think that, how does it work? So Spark is written in a programming language called Scala. Scala, when it is compiled into an intermediary language called Java bytecode, Java bytecodes, similar to when you had a Java program, when you compile a Java program, instead of compile into the native exe, it compiles into Java bytecodes. So Scala as well as Java, both are compiled into the same intermediary language. All right. So in both and therefore Spark core also can basically Spark runs on the same JVM, Java virtual machine, as Hadoop runs on. So both of them can run on Windows, and but general preference of people running these services or running the large clusters, people want to use the Linux. Okay, because it provides you many complex tools which can be used in a very simple way, and so on. So generally people prefer Linux on their clusters, though everything what can be done on Linux can be done on Windows, because both because JVM, Java Virtual Machine, can run on Windows as well as on Linux. All right, and Spark, the entire Spark or entire Hadoop, they both run on Java Virtual Machine. All right. So a question from Robin is regarding the data sources. What's the main difference between? Also, are yes, all of them are under the Hadoop. That's right. The data sources, basically HDFS is like files and folders. HBase is basically providing you a separate service to give you like cell-based editing, and Hive provides you an analytics engine. I think I have answered this question, Robin. Is there a particular question that I wasn't able to answer? They all are under the Hadoop. A question from Ananda is, can you talk something about security on Spark cluster? All right, so Spark cluster basically, yes, it's a good question. Spark cluster basically runs over TCP IP ports, and you have to be cautious about various ports which are being opened. Other than that, you can enable HTTPS or encrypt the communication between various services. So, and again, the Spark cluster, they also open a lot of services parallelly. So you have to be cautious about what is open to the public and what is not. All right. So those are the Just very brief, but if you look at the individual service, which Spark, let's say Spark, let's say if you just take a Spark core and launch it just like that, it will launch Spark SQL thrift service, which by default doesn't require a login password. So that could be disastrous. And therefore, you have to be cautious about using these out of the box on the production environment. All right. That's the briefest way I can talk about security on Spark. All right. And same is true with Hadoop also, because Hadoop, HDFS, all of these are nothing but services that people can use from remote. And therefore, you need to be careful about enabling these services. So you can use a service like Knox, Knox, but that one is not compatible with all. So maybe if you are working in, you want to secure your Hadoop or Spark cluster, you may want to enable the Kerberos security. All right. Question from Pankaj: Spark Streaming and Spark Core are both are same. So Spark Streaming is nothing but a separate class which has like couple of more classes, and which is when run, it is running like an infinite loop, and internally it is using the Spark Core. So Spark Streaming uses Spark Core. MLlib also uses Spark Core. GraphX also uses Spark Core. DataFrame also use Spark Core. All right. A question from Satish is, would we see any example on big data adapter? Okay, adapter or okay, you mean the adapter as in people who are adapting big data? Is that your question? Or adapter as in software components? So, right. So I can talk about the companies where I've worked, where whoever have adapted a big data ecosystem. I'll be talking about those. All right. Great set of questions. Now, let me just, a question from Akshita is this just one class or do we have a continuing class next week? The next class is, uh, we have a next class on Saturday. Those who have already enrolled, they will receive the link. All right, so if you have not enrolled, you can enroll, or also drop me an email at reaches@cloudxlab. All right, so okay, a question from Suresh is, may I know the purpose of data lake? Data lake is a central place where you keep the data from all kinds of sources. And mostly the data lake is nothing but the HDFS storage where the data is kept from all kinds of sources. All right. Data warehouse is again, data warehouse is a place where you keep the data so that you can run analytics on that data. All right, similar concept as data lake, but the only difference between data lake and data warehouse is, in case of data lake, the data is continuously being updated. In case of data warehouse, data is relatively static. All right. Okay, so Hadoop can provide both data lake as well as data warehouse. It is up to your way of using it. Okay, data lake or data warehouse. So Spark can provide you the analytics ability on top of data. That is part of data warehouse, but it doesn't provide storage out of the box. Therefore, it doesn't provide you any data lake or ability to store data. All right. Great set of questions, and feel free to right now. I would like to quickly give you an example of getting started with Spark. Those who are wondering like how to use Hive or HBase, you can take a look at Query Editor and click on Hive and write your SQL queries, Hive queries in Hue. Or if you want to take a look at your, say, HBase, you can use HBase from the menu And in case you want to use Uzi, you can use workflows. Also, example of all of these are available in your MyLab. If you go to MyLab and click on Learn, you will have the videos from everywhere. All right. So here, let's say this is the set of videos that we have created so that everybody can get up and running with the ecosystem. All right. So these are standard Hadoop hands-on videos, so you can take a look at them. Okay. So next is all right. So this we have discussed. Now coming back to say Spark, let me just launch one of the Spark. So here, this is my console. Okay. And let's say I want to do something using Spark Shell. Okay. So I can just type Spark Shell. It will start my interaction with Spark. All right. So this is kind of starting up the Spark. Since it's launching the other service, connecting to HDFS and connecting to the Metastore and Hive and everything, it might take a bit of time. All right. So here is the prompt. Okay. This prompt that you see is Scala prompt, right? Because right now it is essentially Scala. Scala prompt is nothing but here you could type code in Scala. Like I've just typed 2 plus 3 and it has given me answer as 5. I can define variables here in Scala just like normal, right? So I've just defined x as 2, right? I could do calculations on top of it. So this is like plain vanilla. Let me just resize this window or take it out so that it doesn't bleed into the, all right? So this is a Scala prompt, but it has an extra object. It has an extra object called Spark context. The Spark context is essentially the gateway to Spark. This is normal Scala prompt where you can write anything in Scala and it will do the computation, right? Just like we did normal Scala coding. Scala is like this is like a small calculator where you can type expressions, define functions, and use those functions or use the libraries. It's as simple as that, right? It's like a small calculator, or you can say extended version of calculator when you can do things. Now here, you have got one more object called SC. SC is your gateway to Spark. Using SC, we can do many things, right? Here, let's say I want to load some data from HDFS. So I'm saying where lines equals sc.text file. Okay, here I'm passing the location from HDFS. So I'm saying data. You can take a look in HDFS and data slash mr slash input slash sorry mr slash word count. You can open parallelly here in, let's say, in file system. You'll get a picture. Okay, so you can just, let me just copy this place. All right. So here there is a folder called input. We're going to work on this file, let's say big.txt. All right. So let me just copy this. Input slash big.txt. So I'm going to read that file, big.txt file. Okay. So right now it has just made a note of it, whatever we did. Now if we say lines.take and 10, it's going to read the 10 lines from there and give us an array. Okay. So you can take a look at big.txt and here, this is that file. Okay. This is that file. Now, so on lines, we could do many kind of fun, many kind of important operations. Like if you want to do word count, we can do really easily, or we want to break down the let's say we want to break down each line into words. Okay, so let me just define that, where words equals, instead of using a for loop to go over the data, because we don't want to bring all of this data to us. We want to instead send our logic to the data. So what we're doing is we are saying lines and we're saying map. Map executes your logic. It takes the logic from you and will execute against every line in the text. Okay, it is and split it based on space. Okay, so we are saying that split the data in the lines based on space. All right, let's take a look at words. All right, so you can see that I just broke the data into this. Now I can simply say words dot save as text file, and I can save it to my words hdfs. This is the folder I want to create. Here it's going to store it in hdfs. All right, so let's take a look. Did it store or not? I go into my home directory. So okay, so if I just order the data based on the date, so all I did a very simple thing. I loaded a file into Spark, then converted each line into, broke down the each line into words by right by using the by using split, and then saved that whole array into the files. Okay, instead I could have used the flat map so that this could have become a proper function. So let me just change it a bit. Let me just change it a bit. So okay, let me take this, save as text file. Okay, here I could just say something like this. All right, so I can do all these operations in a single shot. All right, so here I'm trying to, let's say, create a new folder called, and let me just correct the typing mistake. So I'm going to convert the whole line into into a series of words. And what does it say? It says that, all right, the file, okay, let's take a look. The file, all right, looks like the data wasn't saved. Okay, all right, let me just delete my previous data. So all right, I think it has already done. This is the temporary attempts. All right, so it has, though it is a temporary and it did not save the result. Okay, so probably some error on some of the nodes. Probably there is a lot of traffic right now. Okay, let me try once more. Maybe this time it might work. Okay, let me just try it once more. Looks like some kind of a system failure.
And it says that could only be replicated to zero node instead of minimum replication. There are 6 running, and all right. Okay, looks like there is a problem with HDFS. Let me just see. Hadoop fs dash mkdir and test 123. All right, this seems to work, but for whatever reason. All right, so maybe we can give it a try at some other time because there are quite a few users, more than 40 users logged in right now. Maybe that's the reason why it's failing as of right now. A question from Akshata is, does typing SC always gives reference to Spark context? So if you are running normal Scala, if you just type Scala and run, then there won't be any SC. There won't be any Spark context. But if you are running, let's say, if you are basically running Spark shell, that's the only wrapper it is. So the wrapper that Spark shell is nothing but a wrapper around Scala. The only role of Spark shell is to create the SC object before launching Scala. All right. So any object you create, you just type the name, it will display the context, display the reference to that object. Great set of questions. So though we were not, we were able to do computation in Spark, though the saving of the file did not happen because of maybe right now the HDFS nodes available for the process are not sufficient, but we were able to load the data from HDFS and do the processing on top of it. All right. So we'll be sending you the recordings and the slides in the email, and and right. So so you will be getting the email maybe tomorrow or by tomorrow evening or so. All right. So thank you, everyone. A question from Satish is, how many users can access the same data and process? That depends on the resources available at that point of time. All right. So it depends on how many workers are there, and we need to check why this HDFS is failing right now, because this is supposed to work pretty well. All right. Thank you, Robin. Thank you, Satish. Thank you. All right. All right. Thank you, everyone. It was wonderful to have all of you in the session. There was a great set of questions, and we covered the entire stack of Hadoop and Spark in a brief amount of time. I look forward to see you in my next session. If you have any questions, you can either come over to a discussion forum. Here, you can take a look at the discussion forum, or you could drop us an email at reach us at CloudXLab. Reach us at CloudXLab. Okay. So you can take a look at the discussion forum. Feel free to answer questions if you are already aware of, or if you are facing any problem, just either drop a message here or reach out to us at Reach us at CloudXLab. A question from Srikanth, do you host any meetups in Bangalore? We do host, but once in a while, but we have mostly online because there are a lot of users globally who want to attend these sessions. And that's why we generally prefer to keep it online. All right. So though we have in Bangalore, we had recently did a meetup at RV College. We did a meetup in Singapore, in IT Bombay, and so on. So we do the meetups physically, but only rarely. All right. Thank you, everyone, and
Thank you, everyone. I hope your questions were answered. And well, all right. In case your questions were not answered, come over to the discussion forum or write to us at reach us at CloudX Lab. Okay, great. Thank you, everyone. I look forward to see you in the upcoming sessions. Yes, go ahead, Srikanth. A question from Srikanth is any updates on BootML? It's coming through to you very soon, probably tomorrow or a day after. Okay. So if you had joined using your email ID, right? So, right, we will anyway get the email IDs. If not, we will look at the chat, then we'll do that. All right. Wonderful to have all of you in the session. I look forward to see you all in the next session. Bye-bye. Have a great day. All right. Thank you, everyone. I hope that I was able to answer your questions. And thank you, Ravi. Thank you, Suresh. Thank you, Satish. All right, sure. We'll be sending you the email ID, email on your email ID with which you signed up. Okay, don't worry. The slides and everything will be shared with you. Bye-bye. Bye-bye. Have a good day. And I look forward to see you. All right, be part of the discussion forum or come over to just take a look at the Linux chapter or Python chapter on our website. All of that is free. We have a lot of course material for free on our CloudX Lab. So come over and be part of it. Bye-bye. Have a great day.